The last one we'll do is let's just start a completely new thing because this is getting a little bit too slow. And let's make neutron star from scratch, from like literally a rock. I'm gonna take a tiny rock. This is one of the minor objects, I guess one of the random asteroids. Place it right here, and this is going to become a neutron star, hopefully, if we don't make any mistakes. Its name is Hork. nice name. So to turn it into a neutron star from essentially an asteroid, we need to remember several things. One is that we have to add quite a lot of hydrogen to it. And so now, just gonna zoom in on it, change this to 20, and start adding things to it. And this is not going anywhere. Why not? Yes, it is. Okay, good. Here we go. So now it's a gas giant suddenly. That was quite a jump. I was hoping it would become... No, hold on. I want to erase this for a second. I was hoping it would become a dwarf planet first. I made a mistake. Made a terrible mistake. Let's add another one. Let's hope it has a funky name as well. I like Hork a lot, but this one is Itaxcunus. That's fancy. That's really fancy. So let's make it into a dwarf planet first. We're gonna basically evolve it into everything possible. So starting with the dwarf planet. Come on, where is it? Hey, here we go. Here it comes. Here comes more rocky stuff for you. So what is going to happen to this asteroid is that after a few increases in mass, it's going to acquire enough mass to become to reach hydrostatic equilibrium. This is where the mass of asteroid is high enough for it to assume spherical shape. This is what happened to Ceres. The dwarf planet is called Ceres, and this is what has not happened to Vesta, because Vesta, and this was actually in the video, in a YouTube video that I explored recently, Vesta is not spherical. Ceres is. Ceres and Vesta are not far off in terms of mass, but one is a dwarf planet because it is spherical. This is a dwarf planet now, and one is not because it is not spherical. So Vesta is technically an asteroid. And Pluto, Ceres, Makemake, Haumea, and Ares are dwarf planets because they have enough mass to be spherical. Now, at some point later, I need to actually make sure I can see what I'm doing. At some point later, this object is going to start becoming more and more massive, and this is when it can start. Sucking in all of the other objects in its orbit, basically absorbing them and becoming this, a gorgeous planet-like object. Okay, now I think this is still a dwarf planet actually. But it will become a planet, and basically the difference between dwarf planet and planet, the main difference that is that one has many objects in its orbit, so that's a dwarf planet, and one has only itself. So Mars and Earth are planets because there's really nothing else in orbit around them. They are very unique. There's really no other objects. They have satellites. They can have their own moons and stuff, but no one else shares orbit with them around the sun. So I think somewhere around this point right here, maybe a little bit more, it's going to become an actual legit planet. Right around, as soon as it gets to like 1,000 kilometers, I'll consider it to be a planet. 1,000 kilometers radius, that is. And here we go. Almost planet-like. Excellent. So this is now a planet. Let's give it a little bit of iron to increase its density, and maybe a little bit of water to make it more Earth-like. Some ices on top, on the surface, a little bit less. Give it some like 0.9%. No, 0.0000001%. No, nothing? Nothing. Come on, get some water. Drink my water, there we go. And the rest is fine. So I also wanted to kind of rotate, so we're gonna make it rotate at a speed of about 1,000 meters per second. No, less. Let's say this much. Okay, good. Perfect. It's rotating. It has iron. It has silicon. So now this is a very small planet, but it's a planet nevertheless. Let's give it atmosphere as well. So we're gonna add some atmosphere to make it into an actual legit planet. And I believe atmosphere is... Where is it? Where's the atmosphere? Should be here somewhere. Motion. Nothing? Should be in the temperature, but it's not here. Okay, so let's maybe wait a little bit. I'm gonna add some carbon dioxide just for fun. More water, and hydrogen. Okay, next thing we're gonna do is we're gonna start adding a lot of hydrogen. So, planets like Jupiter and Saturn acquired a lot of... So first they actually had this. They had a solid core, probably a very massive core actually. And then they started acquiring a lot of hydrogen, because a lot of hydrogen that was not absorbed by the sun was pushed away by the solar winds, by solar pressure into the outer solar system. And because these Jupiter and Saturn and other gas giants were so massive, they were able to kind of capture it. It's kind of like suck it in as they were orbiting around the sun. And as they were absorbing all this hydrogen, they turned into gas giants. So this is the beginning of a gas giant. It's not very pretty though. Unfortunately, it's very, very gray. I actually wanted to have more color, but whatever. So now this is a gas giant. It has... I'm gonna... change its mass in relation to Jupiter. It has a very, very, very small mass compared to Jupiter, but it's gonna get there eventually as soon as I start increasing this in dramatically higher numbers. And so this gas giant is going to grow. It's going to absorb more and more hydrogen that is not absorbed by the sun. And the reason why it's not absorbed by the sun is because the solar winds, the solar pressure, they're kind of pushing things out. This is why there's such a concept as a solar sail, because you could use a solar sail to essentially sail into the outer solar system. The solar winds will constantly push you out. So there's actually quite a lot of pressure on our planet right now as well from the sun. It's actually kind of pushing us out, but just not enough for us to worry about anything, because it's been doing that for billions of years. But if you're a small molecule, like if you're poor little hydrogen or oxygen or whatever else molecule you are, those winds will push you out and you'll be flying into the outer space. Now I don't have to really do it this way anymore. I can just kind of start increasing it this way. So now we're gonna grow our Jupiter. It's going to increase in size more and more. And this is not Jupiter, it's called Itascanus. It's going to be our beautiful star soon. And as it grows, it becomes more massive and massive. So it acquires more mass. Now it's mostly, if you look at the materials here, which is right here, it's mostly made up of hydrogen. And this is what Jupiter and Saturn are like. They're mostly hydrogen. Other gas giants in our solar system don't just have hydrogen; they have other gases as well. But this one will be just hydrogen. So it's now at 10% mass of Jupiter. It's still going to be increasing in size, and it's going to get larger and larger and even more large. Now, because I want it to spin, I'm going to change its momentum in a second. So we're going to go into the rotational velocity and change it to, let's just say, 1,000 meters per second. There we go. It's going to have some momentum. Okay, it's now at 1 mass of Jupiter. It's going higher and higher. It is increasing in size even more. And here we go. 20, 28, 30. So this is when its temperature is going to start increasing dramatically as well. Its surface temperature is going to reach really high degrees of Celsius soon, and it's going to start right about now. It's going to start shining. It's going to start projecting all sorts of radioactive stuff into its outer atmosphere, its outer basically into space. So now it's slowly becoming what's called a brown dwarf. Right around, I think we've established that it's about 104 Jupiters. That's probably the last, basically the most massive brown dwarf you can make before it turns into an actual star, in this game at least. So 104 Jupiters, and this is only because of hydrogen. I think you can make this even higher if you use like iron or something. But here, as soon as I make it 105, ta-da! It is now a very, very, very small star. Now let's start increasing this. I also need to make sure that I disable. Okay, it's not even a button. I was gonna say disable the realistic mode, but it's not even here. So I'm gonna increase the size of this. Now we're gonna change this to in comparison to the sun, and we're gonna go to 1 mass of sun. So right now it's not very bright yet. Its luminosity is relatively low, but it's gonna become brighter and brighter, and brighter and brighter, and even more bright. All right, so now it's more sun-like. It's about 1 mass of the sun, one sun mass, I guess. And let's see if we can take it higher before it decides to explode on us, because I don't want it to explode yet. Okay, looks like it's working. Please don't explode. It is growing in size though, but it's not exploding, so that's good. That's a good sign. 2 masses of sun. Surface temperature of 8,000 degrees. It's now becoming a blue star. And it's now becoming something else. I don't know what it's gonna become like a white star soon. So all of these stars have classification, and they're actually quite complex. And I made a video a few months ago describing different classifications of stars. Hello, Panzer Jagger. How are you? We're about to have our neutron star soon. We're making a neutron star. Hopefully it works. And 6, 7, 8 masses of sun. 9, 10 masses of sun. How high can I go? Oh, okay, not very high. At 12 masses of sun, we had this beautiful supernova. All right, so that's good. So now let's look at the remnant that's here. I'm gonna go back to the remnant, and then I kind of wonder what the mass of this is. It says 12 masses of sun. That's not really possible, but possibly. I'm gonna accelerate time, wait for the supernova to dissipate. And I want to see of what we have here. It's called a Toscanus Nova Remnant, which means that it went supernova because it had too much of a mass. And what I want to do now is, I think as soon as because now it's officially a star, it's been reclassified as a star. If I enable a realistic mode, it's going to supernova again and hopefully turn into a neutron star, because its mass is 12 masses of sun. And I just need to give it a little bit of rotation. A little bit more, actually. And what I want to turn this into, I want to turn this into a pulsar. Let's see if this works. Boom. Excellent. No, not excellent at all. It's still too massive. No, why is it so big? Not massive enough. I mean, sorry. What I meant to say is it's still too large in terms of size. It didn't work. Oh, no, it's not working. There's a specific mass limit here that will make this into a neutron star, but I just missed that. I think I made this too high or too low. Okay, let's try 2.8. Okay, that worked, but now everything is gone. Everything is gone. Where's my remainder of stuff? Oh no, my star is gone. I was hoping to make a pulsar, but it didn't work. 1.7 Altair. Let's see if Altair works. Altair is a star that's very close to us, and if I increase its mass to about 2 something, a little bit more. Okay, Altair is now a very, very large red giant, and now it's a remnant. Okay, that didn't work either. Okay. Serious. Can you become a neutron star for me? Can you please become a neutron star? Okay, let's try this again. Sun. And I need time now? Nope. No. Nope. Nope. It's not working. It's not working. I maybe need to do something a little bit different. I may need to just wait. And we're gonna wait a long, long time. So this is evolution of Sirius. You can actually see its age right here. Currently it's 250 million years. And we're gonna accelerate this until it gets really, really old. Like 400 million years. And you can see its temperature is actually decreasing because it's burning up all of this stuff. VW Canis Majoris might work. I think it's actually too large. Canis Majoris might turn into a black hole, unfortunately. But Sirius, look at that. It's even changing colors. Changing colors, increasing in age. So this is about to become 1 billion years old. Temperature is decreasing, size is increasing. And this is evolution of Sirius. It will eventually become a very large red star. And then it's going to do this. Expand. And please become a neutron star for me. Please do it. No? Not yet? No, not yet. I mean, not a neutron star, just a small yellow star, orange star. Alright, let's try Canis Majoris. Okay, what happened right now is that I forgot to turn on the realistic mode, and as soon as I did turn it on, it went into supernova again. So, yeah, okay. As soon as you turn the realistic mode for Canis Majoris, it just explodes because its mass is so large already that this game does not allow it to stay as a star. Even though in reality it is a star. But this is what happens. It becomes a super, super hot, superheated supernova. Let's try Scuti. UY Scuti. It's another very large star. And we're going to try this again. So this is 8.5 masses of sun. Yes, the age of stars does make everyone realize how much insignificant we are in comparison. I think games like this, and also games like Space Engine especially, make us wonder, or make us think about our insignificance in the universe. Ooh, that is so cool, look at that. What just happened? It turned into a very, 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 very dim, very cold object. That is so cool. That is awesome. Look, it's so dark and black. I don't even know if that's even possible because it says its surface temperature is 0 degrees right now. Pretty sure that is not possible. But you know what? Let's run this. Let's see where it goes from here. Becomes a red star. Mass 1.15 masses of sun. Very close to our sun mass. Then it cools down again. And what happens? It's at 800 degrees. This is actually what is going to happen to our sun eventually. When it becomes a white dwarf, it's going to extinguish itself in this matter as well. It's going to slowly run out of juice and die. That's going to happen in about 10 billion years, maybe more. Alright, so looks like we're not going to be able to do a neutron star in this particular simulation because in the new version something has changed. What I used to be able to do is I used to be able to create a massive star about anywhere between 3 and 4 masses of sun, wait for it to kind of live its life, and then eventually it would actually become a neutron star. A neutron star is very, very, very massive, but also very small. It's only about a few kilometers across. What happens if I make a sun that's about 100 masses of sun? A black hole, of course. Alright, that's cool. That makes sense. But why does it not do it with a smaller mass? Because right between the black hole and a white dwarf, there should be a neutron star. Alright, so, you know what? I think I'm gonna pause this here. Mostly because I did accomplish what I wanted to do. I did create a sort of terraformed system around a smaller star. So one of these things is what I wanted to have at my center of my sort of solar system. And then what I wanted to do is I wanted to essentially create a terraformed world around it. But the thing is, I discovered that in the new alpha, it doesn't really allow me to use that radiation to heat up other planets. So if I were to place I were to place a planet here, let's just say, let's place Pluto. If I were to place Pluto orbiting around all of this madness and nonsense, you'd see that it doesn't really get any radiation from it. No radiative power, even though this thing is supposed to be radiated. Oh no, Pluto! Oh, Pluto's gone. So I think that's possibly a bug as well, or possibly a new feature that is not really a feature, but I was kind of sad that I couldn't really do it. So let's just run the simulation, see what happens to it, how it advances. And what I'm gonna do is, I think maybe next weekend, I'm gonna possibly make a slightly better plan. We're gonna possibly create a completely new system or something. We're gonna do some more simulation using this game. But for now, I think I'm gonna stop this here. And if you did enjoy this stream, subscribe, but also check out my YouTube channel. There's quite a lot of videos I do on the YouTube channel with the Universe Sandbox too. There's going to be more videos coming up this week as well. Here we go. This is what I was waiting for. I wanted to see things collapse. And the beautiful explosion. Let's actually, I'm gonna detonate our wolf. Boom. Haha. Oh, it's a supermassive black hole. Okay, so I think this game doesn't actually have this black hole yet. But I'm sure it's coming. Anywho, thank you guys for subscribing, for following, and for watching the stream. Check out the YouTube channel. It's basically all about mathematical and scientific concepts explained through video games. And that's what I do in this particular video or on my channel.